Scaling web applications can be really challenging at times, and this is one area that I don't really see good advice often. I think advice when it comes to scaling applications is usually pretty exaggerated. It's important to note that most of us are not aiming to have Google scale or Twitter scale or Facebook scale. Some of us are working in high traffic, high scale applications, but not many of us are working at that level. And if you're dealing with Facebook level traffic, then you probably have a team of very competent engineers to figure that out for you. And then this video is not for you. But if you have a regular PHP or Rails or JavaScript or Go application, and you're facing an increase in traffic and you want to get ready, or you're already dealing with scaling problems, then on this video, I want to touch base on a few basic techniques that should give you some orders of magnitude in performance, regardless of the language, of the framework, of your tooling. We're going to go through the basics, and then if you apply those basics and it's still not enough, then you probably have a fairly big problem in your hands. And more likely than not, you can already hire a group of very competent folks to figure that out for you. But I don't really like advice such as rewrite this in another language or introduce this very complex tooling. Let's move to Kubernetes, Terraform, Kafka, Prometheus, and Grafana, rewrite all of our services in Go. I don't think that makes a lot of sense to mature products. Sometimes it does make sense to rewrite something in another language, a specific service on endpoint, but you can apply lots of really good foundational techniques to give you a major boost in performance without having to go that far. So let's go into Excalibur and take a look at what a simple application might look like. So what we have here is an example of a fairly standard web application. You have users making requests. Maybe their request is going to hit something like Nginx. Maybe it's just going to hit your web server directly, your application server directly. And then Nginx might check static asset. If it is, it just sends that as a response. If it's not, then maybe you're calling something like PHP, or you have an application server that's going to be called, and Nginx is acting as a reverse proxy. So in that case, you would talk to something like, let's say, PHP. PHP would then talk to maybe a database, maybe some third-party APIs, and then it would give the user a response back. So when you reach the situation, you might start to have, let's say that you have this application fairly standard. You have a database, you have clients, you have third-party APIs, and you're dealing with some scaling problems. There are a lot of things we can do here to speed things up massively without having to switch languages or change databases or do any of these things. Let's go through the basics. One of the most important things when it comes to scaling applications is having enough data. So if you don't have something set up yet, this would be the perfect time to set up New Relic or Datadog, or if you want to go the Prometheus and Grafana route, you can also do that. So let's say that you have, let's go with New Relic. You have New Relic as your application performance monitoring tool, and let's make that rad. So you probably have Nginx setting information here, you have PHP setting information here, and you have your MySQL database setting information here. Maybe if you use AWS, you could have some CloudWatch dashboards to give you some insights on your application's performance. But this is really important for a few reasons. First, you want to know what problems you have. Is it RAM related? So is it memory? Is it CPU? Do you have CPU bound workloads that are making your application either go slow or not be able to handle those requests? So having data is the most important thing. You don't know where to go if you don't know what the problem is. So let's assume that you have that data, and let's also assume that Nginx is properly configured. So we're going to get that as green. Now, the second thing that you want to make sure is that your application is optimized. I recently wrote an article about optimizing PHP, and I was surprised by how many people didn't know of some basic things like OP cache or PHP FPM configuration. And the same happens, I imagine, in other languages. If you have a Java application, maybe you can fine-tune the JVM a little bit, or if you have a Node application, you can also configure that so it's suitable for your servers. Let's say that you have a server with 8 vCPUs and 32 gigs of RAM. You want to make sure that your application can utilize that to its full potential. So you definitely want to have that fine-tuned, if you will. This is pretty basic, so I'm sure you guys know all about this. Then it comes the database. Within your database, you want to make sure that you have a bunch of things. So first, do you have your data well organized? Do you have the proper tables? Can you maybe denormalize something or normalize something to increase performance? But more than that, do you have the correct indexes in place? And do you have enough data going into your relic? Can you spot which queries are slow? Can you maybe check what the query planner is doing on those queries to make sure that you can optimize them? Because here's what happens. If you get a lot of traffic, and I'm going to use a database as an example because that's probably the most basic additional system you have with your application, with most applications. I think it's fair to think of this as a distributed system. You have your application, your web application, like your PHP application, and you also have a database at least. So do you have enough data to know what's going wrong here? Do you know which queries are slow? Do you know why they're slow? Is it because an index is missing? Is it because you're doing something that it's not optimized for? Because it's also a thing. And in those cases, it might be worth trading your storage engine. But usually it's throughout my career, what I've seen is mostly indexes. It's either too little indexes, so you don't have the proper indexes for the queries you're running, or too many indexes. I've seen people index everything, and that's going to make your writes very, very slow, and it's also going to consume a lot of disk space. So let's assume that you've got that figured out. So you've done the basics. You've optimized your application, you've optimized your database, you're making as little calls as you can to third-party APIs, and you have data going in into some monitoring tool. What can you do from here before you think about Kafka or about distributed systems or about microservices or anything like that? First of all, you have caching, and you can have caching at different layers. Let's start with maybe the most basic one. If you have queries that are being run frequently and maybe you can handle stale data or you're getting the same data frequently, you can probably introduce some caching here. So let's add a layer here. And we're going to make that purple. And we're going to call this caching. So if you add a layer between your application and your database, it means that if you have your data in the cache, you no longer have to hit the database. And that saves running queries. If you have connection pooling, that might not make a huge difference when it comes to connections. But if you don't have connection pooling, that also means you're saving one connection unless you're executing other queries. Either way, this would also already give you maybe a relevant performance boost, especially if you have slow queries. So sometimes you have things like reports, and sometimes reports are bound to be slow, even with the right indexes. Sometimes they're just extensive. You're talking about a lot of data, and there's no way around it. So one thing you can do is you can cache those results, assuming they don't have to be real time. You can have a bit of stale data. So you can cache those results, and then instead of hitting the database, you just hit your cache, which could be, let's say, Redis. So, ooh, that's big. Let's add Redis somewhere here as sort of another tool we're using. And then you just pick that from Redis. Redis is extremely fast. Obviously, it has very limited data structures, but for what it's supposed to do, it is a great, fantastic tool. So you've added caching here, and this is going to solve lots of problems when it comes to long-running queries, so expensive queries, or when you're just calling the same query constantly. Let's say that you have maybe, here's a good example. Let's say that you have an endpoint that fetches currency conversion. So you want to see how much a USD is worth in BRL, which is Brazilian real. You might think, okay, you have the currency being updated very frequently, maybe to the second, if you're an exchange or something. Let's say that you're Binance or something like that. Can you cache that? You can definitely cache that, because think with me, even though you're updating that by the second, you're still getting maybe, let's say that you're getting thousands of, let's say that you're Binance, you're probably getting thousands of requests a second to that specific endpoint. So you can definitely cache that, even if your cache key time to live is going to be 1 second. Even if you have that for 1 second, you're saving a bunch of database calls. So we got it here. You can also add caching at other layers, if you will. For example, let's say you have an endpoint or you have even a page, let's say that you're a newspaper. Newspaper have news, and those news are not updated frequently. So instead of even reaching your application, you can just cache at the server level. So you could probably, how do I get this in between? You could probably add a cache layer here. You could use something like varnish. So instead of even hitting PHP, you just have that page loaded in the cache and you just return the page. And obviously you probably don't want to do that to every page, maybe to the top 100 or top 10,000 pages being visited, something like that. But the point is, you don't even have to hit PHP. You probably want to have some dynamic pieces and you can do that. But for the most part, you don't even have to hit your application. So you can also add caching at the server level, which is pretty common as well. And let's say that you're using something like Cloudflare or just a regular CDN. So before this request hits your server, they would go through something like, let's say, Cloudflare. Can we make that yellow? Okay, that's good enough. If it is going through something like Cloudflare, you also have caching at the edge. So Cloudflare is going to cache your static assets, obviously, if you enable that, and some other things. So this is also going to speed things up because for some specific URLs, you're not even going to hit your server. Cloudflare is just going to return a cached response. So between those 3 cache layers, you can save a bunch of bandwidth and a bunch of really application usage in all senses, the database, to your actual application, and even to your server. That should already give you a massive performance boost. Now, with caching, you do have problems, or rather trade-offs, like cache invalidation. What if you have in use and someone adds a comment? You don't want to show a stale page. So you would have to invalidate that cache. And then you got to think, is this an operation that caching makes sense? For news, for example, for a news page, I think it definitely does make sense. You don't have comments being added that often. And even if you did, you just have to revalidate the cache. If you can serve one uncached response for every 5,000 requests, that's great. You just saved, 999 requests. So that's also a massive performance boost. In some cases, you cannot just cache the entire response like we'll be doing here. You have to do some calculations or you have to do some authorization or something like that. And then caching at the application level would be best. But that can already save you lots of resources. Now, another thing that we can do here is sometimes you have operations where you don't really have to process something immediately. I'm going to give an example. You probably know Jack Ellis from Fed Analytics. They deal with large scale, and they're a lot of application. They're basically a competitor to Google Analytics, although they're much better. And their traffic's really the sum of all of their clients. So they get a lot of hits to some of their endpoints, I imagine. And they don't have to do some operations immediately. Some operations can be eventually consistent. Let's say that I visit a site and we want to store a record saying that I visited the site. You probably do not need that record to be stored in the database alongside the request. The user doesn't have to wait for that. You don't have to connect to the database or not. You can offload that to a queue. So if you have a queue here, and this could be, you could have a Redis-based queue, you could have SQS here, you could have RabbitMQ, etc., etc. If you have a queue here, you can offload a lot of work, a lot of maybe CPU intensive or IO intensive work to this queue. And then you can just return your response immediately to the user. And you have 2 benefits here. The first one is, think with me. Let's say that you get 10 requests. Each request takes 100 milliseconds. And let's assume that you only have 1 core available and you can only do one thing at a time. So you're going to take 1 second to respond to all of those 10 requests. So you're going to take 100 milliseconds to respond to the first one. You're going to pick up the second one. So maybe a little bit over 1 second, but you get my point. That's because you're also connected to the database and maybe you're also talking to a third party. But if you can offload that work to a queue, it means that you can return the response immediately. So maybe those 100 milliseconds can be shaved off to 75 or maybe 60 milliseconds. And that means that within that 1 second time frame, you can handle more requests. The second benefit is that IO work, which would be maybe writing something to the database or talking to a third party, is now offloaded to a queue that's going to execute that asynchronously, so at a later time. And within your queue, you don't really have to worry about giving the user a fast response as you have to do on a synchronous context, as in a request context. You don't want the user to wait for a lot of time, etc. So you can just leave that in the queue, and obviously, you're probably going to have different queues with different priorities and goals. So maybe you have a specific queue that's meant for, let's go back to the Fathom Analytics example. It's just meant to store a visit to the database. That doesn't need to happen immediately. And if it's delayed for a while, maybe it's not a big deal. So you can set up a given number of processes or worker to deal with a queue. So if it gets backed up a little bit, let's say that at some point a day, it's going to take 15 minutes to empty that queue specifically. It's not a big deal because it's not a problem. It's not going to be a problem to the business. And maybe you have some queues where that would be a problem. So you allocate more resources, you store less jobs in those queues, etc., etc., etc. So you can balance those queues as you want, and you have more granularity, if you will. So we already have caching, we have indexes, we have caching at the edge, we have caching at the web server level, we have queues. With those things, I can guarantee you that you're going to have a massive improvement in performance for all the reasons I mentioned. And you can also do a few more things. So you can obviously scale vertically. So you have a server, you can make it beefier, and you're going to be able to handle more requests. But you can also scale your application horizontally. And that's good to at least have some redundancy. So instead of having one single PHP application, we could have multiple. So you could have multiple applications here, and then your requests would actually go through a load balancer. So you would have here at some point, it would be before Nginx maybe. So Nginx would ship with PHP really in this scenario. So this really represents a single unit, which is your application. So let's call this app. And then instead of going straight from Cloudflare to this specific Nginx instance, you could instead redirect this request to a load balancer. And this load balancer would then be responsible for passing the request to one of your application's instances. Yeah, this doesn't look good. You guys get what I mean though, don't you? So this load balancer would then pass a request to one of these Nginx instances. So if you're getting a lot of traffic, you have your database, you have your applications, you can just spin up more instances of your application. Right now, you only have one Nginx and one PHP. You could double that and you'd have two of your application. And then the load balancer would round robin or use some other strategy to distribute requests between those. And then you would be able to handle more requests. Obviously, you need to know where your bottleneck is. Let's go back to the database real quick. Right here, we are considering that we only have one database instance, but depending on your traffic patterns, your database usage patterns, you can split those into two instances. You could have a writer instance and you could have a reader instance. So you could have a replica. Let's think about that. Let me rearrange this a little bit. Okay, cool. Here we go. So we would have, for example, a writer instance and a reader instance, and then the writer would feed data to the reader instance. What's the benefit with this? If you have different workloads for writing and reading, and you probably do, your application probably reads a lot more often than it does writes to the database. So you can scale those differently and you can have separate instances for those. And what you can do is your application would mostly use the reader instance unless you have an operation where you're going to write something. And I know that GitHub has had a lot of success in its early ages with this strategy. I think they have a blog post about this. If they do, I'm going to link this in the description. And the benefit with this is, like I said, you have different traffic patterns and write patterns and load patterns for those. So if you can split them, you can deal with them differently. So if you're just visiting a page, let's say that you're visiting that news page, you're going to read that off the reader instance. If you're adding a comment to a news, then you're going to use the writer instance because you want to insert data. Now, obviously, you probably want the reader instance to be read-only, etc., but those are details. With that strategy, you can split your traffic and you can use in your workloads on your database. Your reader instance is only going to read and you can be optimized for that. And your writer instance is only going to be used mostly to write data. There is one situation where you probably want to read from it, which is just after you wrote to it. When you have a replica setup like this, your data on the reader instance or the reader instances, you can have more than one, is going to be eventually consistent because it will have to be replicated from the master instance, if you will, to the replicas. And that may be real fast. It might be like 5 milliseconds, 6 milliseconds, but maybe it takes longer. And you want to make sure that if you just wrote something to the database, you want the user to be able to see the changes they made to a particular row or table. So when you just wrote something, you probably want to use the writer instance for at least the next request or for the next 10 seconds or something like that. And I know that Rails supports that out of the box. I don't know if Laravel does, but that's also something you would want to do. In general, you would use the reader instance. If you just wrote something to the database, you would use the writer instance just to make sure that you had the data. And you know that at some point, maybe a few milliseconds later, the data would be replicated into the reader instance. That's also cool because you can create fallout strategies. So maybe if the writer instance goes down, you can escalate the reader instance to be the new master instance. But the point is, if you split those, you can deal with your traffic patterns a bit more, rather with your write patterns a bit more. So here's what we have. We started with just the user talking to Nginx, that talked to PHP, that talked to the database, and to a third-party API. What have we added? Well, we have added caching at the application level. So your application is calling your cache service like Redis, for example. We've added caching to the web server level. So before it even hits your future application, you can also cache some data and return the response immediately, which will save you a bunch of CPU time. And we've also thought about caching at the edge. That would be Cloudflare in this example. So for example, your static assets, they don't really have to be served through Nginx. You can have Cloudflare serve them. We thought about queues. So we want to offload work into queues whenever you have something that's going to take a while, or whenever you have something that doesn't have to be processed immediately, consider offloading that to a queue. There are other benefits to queues, and we could talk about that in a different video. But the goal is to always give the user a response as fast as possible. You don't want to leave requests hanging. So if you have some sort of either IO intensive task or CPU intensive task, just give the user a response immediately and offload that work to a queue and have that done in the background, maybe even by a separate server. Just like you have the server run your application, you could have different servers, maybe one or maybe multiple of them, to deal with the queue itself. And in that sense, you also gain the benefit of having those two contexts split. Your application is not going to go down because your queue is full, and your queue is not going to be backed up because your application is under heavy load, because they are separated. And then we also talked about databases, about maybe having a replica setup where you can split your writes and your database activity between the two of them and use whichever suits you the best at a given time. So mostly the reader instance, because most of the operations are read operations. And whenever you want to write something, you just write that to the master database, and then the replicas are going to follow that. But again, it's eventually consistent, so you want to be careful with that. And then one thing we didn't talk about is third-party APIs. And third-party APIs are complicated because it really depends on what you're doing. If you have a critical service like, let's say, a payment gateway, then there's not much you can do. You just have to wait for it. But even payment gateways can be offloaded to a queue. For example, if you buy something at Amazon, I'm not sure if this ever happened to you, but if you try to buy something and you enter a card that doesn't have enough funds or something like that, you're still going to get a order confirmation page thanking you for purchasing something. And after maybe a few seconds or a few minutes, you're going to get an email saying that your card was not, the chart didn't get through on your card. And that's probably what I imagine is they're offloading that to a queue. So when you purchase something, when you make an order, they place your order immediately, they give you a response immediately, and then they try to charge that order in the background. And if it fails, you get an email, they let you know. You don't have to be, you can be a little bit more optimistic. Maybe you can load the order page for the user and you can keep polling it to see if you got a response already from your payment gateway or whatnot. But you can also offload that to a queue. Obviously, that's something that this wouldn't be my first priority in most applications, but you can also do that. So whenever you're talking to a third-party API, more often than not, you can also offload that to a queue. And more often than not, that's work that doesn't have to be dealt with immediately. So obviously, you can put that behind a queue. And sometimes, depending on what the response is, you can also cache it. Going back to the Binance example, let's say that you're fetching currency exchange prices and you're a consumer, you're not Binance. So maybe you don't have to be precise to the second. Maybe you can be precise for every 5 seconds or something. You can just cache that Binance response. First, because you're not going to hit your rate limit with Binance that fast. And secondly, because you're going to have much faster responses. Let's say that the latency between your machine and Binance is, I don't know, 40 milliseconds. Well, you just saved 80 milliseconds because you have a round trip. So little by little, you can shave off a lot of latency and increase performance in tiny bits. But when you have a high scale environment, when you have a lot of requests coming through, those minor advancements make a huge difference at the end of the day. And obviously, just recapping, you need to have data. If you don't have data, you don't really know what's wrong. You don't really know what to optimize. So whether you go with New Relic or Datadog or Grafana, you should have that. Now, something we didn't talk about was infrastructure. I don't want to touch on that subject primarily because I'm not really good at it. So I don't want to give erroneous advice. But you probably want to have your application Dockerized, at least just to make, if you want to scale it horizontally, a little bit easier. But for most scenarios, I don't think you need to really go the Kubernetes route. You have plenty of tools that are going to accept containers. Pretty much any major cloud service is going to accept images and deploy them for you. So if you have your application Dockerized, it's just going to make deploying your application a little bit easier. So I don't want to get too much into the subject. Not something that I enjoy, to be honest. But yeah, that's also important. Believe it or not, OBS just crashed and I thought I had lost this recording. But yeah, this was a very quick video. It's not really something I thought about before. I just loaded up Excalidraw and draw something. But I hope that helped you. Let me know if you have any doubts or if you have any suggestions, or if I said something that doesn't make sense, feel free to leave a comment and I'll pin it up or put it on the comments. I probably said something that doesn't make sense. I do that often. But yeah, my general advice is if you're dealing with high traffic or if you're having to scale applications, before you look into very complex things like rewriting services in different languages, introducing things like Kafka. Kafka is fantastic, by the way, but Kafka is a distributed event stream. It's meant for distributed applications that need to run with low latency, etc., 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 which is not the case for most applications. So just going with the basics, caching at the appropriate places, well-optimized server and applications, well-optimized database with indexes, maybe splitting your reads and writes. That's already going to make a lot of a difference, and it's probably what's needed for most applications. It's probably enough for most applications. Horizontal scaling, database optimizations, caching at the right places, and offloading work to queues is already going to do wonders for most applications. If you're at a level where that's not enough, then you're also probably at a level where you can afford hiring very smart, much smarter than me folks to figure that out for you. And then this video is not meant for you. With that said, as usual, thank you for watching and I'll see you guys on the next video. Bye-bye.